Hi everyone. We are here to do section 6.2 substitution. The last lesson was on section 6.1, which was solving by graphing. Well, you don't always have to graph things. You could do it algebraically. So we're going to do some algebraic solving of systems. Remember, it all comes down to where would a system of equations, two variables, intersect on a graph. But you don't always have to graph them. We have alternatives. So, first of all, a system of equations. We know it's two or more equations, and substitution is another method to find the solution. To solve a system, first of all, take one of your two equations and solve it for the variable. So if you've got a 2x minus y, now let's change that. If you've got an x minus 2y equals 8, I could easily get this x by itself by adding 2y to both sides. And now I've got x equals 2y plus 8. I just solved for that variable. Second step is to substitute that value into the second equation. Once you do that, you're not going to have your two variables anymore. You're only going to have one, and you're going to be able to solve it. You actually do a second substitution. You find the value of the other variable by substituting in what you found first. And then last but not least, write your answer as an ordered pair. So substitution is exactly what it sounds like. So let's do a practice. First practice, it says y equals 3x, and then it says x plus 2y equals negative 21. The first thing I look for, is there a variable all by itself? When I look in this first equation, this y is all on its own, right? It's already done, it's solved for the y. So in the other equation, since it tells you that y equals 3x, wherever I see a y, I could put a 3x in place of that. I could substitute 3x for the y. So instead of x plus 2y equals negative 21, I'm going to substitute in 3x for that y. Now, if you notice I've only got x's, I can solve an equation if I've only got x's. So I'm going to do the math. X plus 2 times 3x is 6x equals negative 21. I'm going to combine those like terms and then divide both sides by 7. So x is negative 3. Pretty simple. We could have graphed these and we'd find out where this intersects, at least half of it so far. We are not done though. Your answer is an ordered pair, so we need to find out what y equals. Well, if I go over here, it told me that y equals 3x. And I just found out, if I trust my math, that x equals negative 3. So I bet that everybody's pretty easily going to be able to do the math to figure out that y equals negative 9. So my solution to this system is negative 3 comma negative 9. X is negative 3 and y is negative 9. Look good to everybody? So let's talk about infinitely many. I've got another one. Feel free to do that as an example. Infinitely many solutions. We talked about this when we talked about equations and other things, but we have this for a system, and we had this when we graphed the system. Infinitely many solutions meant when we graphed them, they were right on top of each other. So infinitely many says after substituting, the variables cancel each other out, and you end up with a true statement. So let's look at one like this just so you can see it. Our system is 2x minus y equals 6 and 3y equals 6x minus 18. Unfortunately, we don't have any variables by themselves, but we could make a variable by itself. I noticed that this 3y is almost, the second equation is almost by itself. What could you do to isolate the y in this equation? I'd divide everything. Don't forget to divide everything by 3. So I'd have a y equals 2x minus 6. So now I'm telling you what y equals. So in the other equation, always go to the other equation. Wherever I see a y, I could substitute in a 2x minus 6. This one we're just going to be careful. So instead of 2x minus y equals 6, I'm going to substitute in. I always put parentheses around my substituted value. And here's a good example why. Because when I put the 2x minus 6 in for the y, that means I have got to distribute this negative or negative 1 sign so that I can get rid of my parentheses. So 2x, negative 2x plus 6 equals 6. I've got a pair of like terms right here. What is 2x minus 2x? So when I end up with 6 equals 6, that's a true statement. There are no variables left. So all I would say is that this is infinitely many solutions. I know if I graphed these guys, that they would be right on top of each other. They would be the same line. Infinitely many solutions. Our one other case that we could have is no solution. No solution, much like other ones we've talked about. After substituting, you have no variables and a false statement. If we graphed them for no solution, remember those lines would be parallel. So let's do one last practice for solving a system by substitution, and then I'm going to give you some things to think about. So for problem number 4, there are no variables isolated. I see really easily, I'm going to get this y by itself this time, since we haven't isolated the y. Have we? Oh, I guess we have. How about let's get the x by itself then? Just kidding. If I want to get the x by itself, I'm going to subtract y from both sides, which means I'm going to have x equals negative y minus 2. So in other words, I'm telling you what x equals. So in the other equation, wherever I see an x, I'm going to substitute in that negative y minus 2. So instead of having 2x plus 2y equals 8, I'm going to have 2 with a negative y minus 2 plus 2y equals 8. Again, put parentheses around your substituted stuff because when I distribute, that's going to make a big difference. So I've got negative 2y minus 4 plus 2y equals 8. And now I'm going to combine my like terms. So I've got a negative 2y and a plus 2y. So those guys cross out. All I'm left with is negative 4 equals positive 8. I hope you agree that that is a false statement. There are no variables left. So we've got ourselves no solution. Again, if we graphed this, these would be parallel lines. They would never touch each other. So there is no solution. There is no point of intersection. So there's some more examples on your note sheet if you want to do more examples. However, I do have 2 things that I want you to do before you come to class. First thing, do more, actually 3. Do more problems if you need to, because there's more practice problems. Answer this. What's one question you have about solving by substitution, or what isn't quite clear? You need to actually answer that. Write down a question, write down something you're not sure about so that we can make sure that we talk about it. So think about it, go back and look in the examples if you need to, but one question that you have about solving by substitution. And I want you to do, I hope there's enough space, this practice problem. Solve this problem, this system. Y equals negative 4x plus 12. And your other equation is 2x plus y equals 2. You should get whole numbers, no decimals or fractions when you solve. Don't forget your answer's an ordered pair, so you need to make sure you find out what x equals and what y equals.